Alright, hello, this is Max. We're looking at Spring 2013, Midterm 2, Question 1. You will be baked and then there will be cake. Okay, assume that you've started Python 3 and executed the following statements. So this is a what would Python print problem. And whenever I see a what would Python print problem, I like to sort of make sure that I'm drawing out these values and using pointers and stuff so I can actually keep track of them. If you want to like explicitly draw an environment diagram, I think that's helpful. I'm just going to sort of draw out, since we're only working with lists here, it looks like, I'm pretty much just going to draw out a bunch of box and pointer diagrams. So do whatever you feel comfortable with, and but it's really, really helpful to draw out sort of the flow as we go through this. So I'm going to start out by drawing the cake. Okay, so the cake is going to have 1, 2, this is a pointer to another box 3, and then 4 and 5, right? And now we have a lie that's equal to a slice of the cake from 1 to 4. Slice cake, get it? Okay, so a lie, I'm going to draw that, I'll draw that right here. All this is saying is that if you, the values, so what you should write for each thing. So if the value, as we're evaluating this, we want to sort of write what each of these expressions evaluates to. If it evaluates to a method, we'll write method. A function, we'll write function. If it's going to error, we'll write error. And if it runs forever, we'll write forever. So I'm going to draw over this, but you probably shouldn't do that in the exam. Okay, so let's see what the cake is. So the cake, we're indexing from 1 to 4. Remember, these are the indices of this list. 0, 1, 2, 3, 4. And when we index from 1 to 4, we're going to not include this right element. So we're going to go from 1, we'll include 1. And we'll go until right before 4. And we're actually making a new list, so we're making a copy of this right here. So here we have 2. This is actually a pointer to this list here. So we've copied this pointer, this reference to this list right here. Not the actual list itself, so we haven't made a new list, but we haven't made a new list when we talk about this 3 right here, but we have made a new list when we talk about a slice of cake. And then 4, right? Okay, cool. So that's a lie. This is the cake. Okay, now we're overwriting the cake to be a slice from the cake from 1 to 4, which is exactly the same as this. And it's a new list, but erase this and erase this. So now we've done from 1 to 4. Now the values are 0, 1, 2. Okay, and then 0, 1, 2 here. And now great is equal to a lie, so we'll have a new variable great. It's going to point to the same list here. Delicious is equal to the cake. We'll say delicious. This is the cake. Points here. Delicious points here. Moist is equal to great, except for the last element. So sliced, not including the last element. So we'll say moist here is going to point to something that is just 2. And it pointed to 3 here. Okay. So now that we've drawn that out, we can start going through our questions. Okay, the cake. Well, this is a list. It's going to look like 2, the list of 3, and then 4. Whoops. 4. The cake is a lie. So the cake and a lie, while they are equivalent, are not the same object in memory. And so we're going to say the cake is a lie is false because they don't point to the same object in memory. If both of these pointed to the same object, then this is statement would be true. So here we're going to say this is false. The cake equals great. So this is the cake. This is great. And since they have the same, they're going to evaluate to the same list in terms of their contents are the same. And so we can say that even though they're not actually the same object in memory, since they evaluate to the same list, each of their elements is the same, I'm going to say this is true. The cake is delicious. So this is the cake, points to this object in memory. Delicious points to this object in memory. So we can say this is true, since they point to the same object in memory. We're on the right-hand side of our environment diagram. The cake equals moist plus 4. Okay, so let's make this function call. Moist is going to be some list plus 4. Doesn't really make sense to do an operation between a list and an integer that's plus. If this was a list instead, it would mean concatenation, but there's no sort of intuitive way to add a list to 4, so we're going to say that this is going to raise an error. The cake.append. Well, so append is a method of a list, and specifically here, it's a method of it's a method bound to the object the cake, the list the cake. So, well, this is going to be a method either way because we're not calling it. If we did actually call it, it would return none. It's a method that is sort of non-pure and doesn't return anything. The cake.append equals a lie.append. Well, the cake.append is a method append bound to the object list the cake, and a lie.append is the method append bound to an object list a lie. And so we're going to say that these are not equal to each other because they're bound to different selves. So we're going to say this is false. The cake 1 is equal to a lie 1, so what's the cake 1? The cake 1 is this. It points to the list 3. What is a lie 1? A lie 1 is this. It points to the list 3. So since these both point to the same object in memory, we're going to say that this here is true. Okay. So if you have any questions about this, feel free to post on Piazza or write a comment on YouTube and we'll try and get them answered. Great. Thanks for watching.